Hi, this is Jeff Minter with Automotive Research and Design, and I'm here today with another hybrid vehicle tech tip brought to you by P10 Magazine. Today's tech tip will go over the hybrid vehicle inverters. We'll discuss what they do and some of the components within those inverter assemblies. If you're not already familiar with inverters, you may be wondering what all they do in the hybrid vehicles. Well, one of the main functions of these is going to be to generate the waveforms that are used to drive the electric machines, also known as electric motors, when they're providing motive torque to the vehicle. Another one of their functions is to rectify any AC voltage and current that's generated by the electric machine when it's serving as a generator. And this could be while it's serving as a regenerative braking function, or while it's being driven by the engine as a generator assembly. Next, of course, during the regenerative braking, we need to have a way to control the amount of regenerative braking that's being applied to the wheels, as well as how much current is allowed to go back to the battery pack. So the inverter is going to regulate that amount. And last but not least of the things that we're going to look at right now anyway will be the boost and or buck reactor system. It's a system that allows it to either step up or step down the voltage that's coming into or out of the motor assembly based on the current operating needs. Now, the boost reactor is not used on all vehicles, but it is becoming more common. This block diagram on the screen is a very basic rendering of what would be inside of inverter assembly, or at least some of the major components. As you can see over to the right side of the screen, there is a three-phase Y-wound motor assembly displayed. We also then have the inverter shown in the center in blocks. You notice in that inverter we have several blocks called IGBTs. Those are what are known as insulated gate bipolar transistors. Those are going to be the devices that switch the current and voltage on and off to the three-phase machine. And those are going to be what actually are used to generate the waveform. You'll also notice that we're showing three current sensors just to the right of those IGBTs. All vehicles will have at least two current sensors, but in this instance we're showing three, which is something that you see on some of the vehicles. One of the other major components that I wanted to show in a picture versus just a block diagram are the high voltage capacitors. These are attached to the DC bus within all inverter assemblies in the electric drive systems. These are in there for something called power factor correction. If you're interested in learning more about that, just search power factor correction and you should find a fair amount of information of that online. For an example of how technology is changing and how things are getting more compact, I thought I'd display the three different vintages of the Toyota Prius inverter that are out there right now, running around in different vehicles. So if you notice on the top level one, we see the 2001 to 2003 Prius inverter. This was a relatively large unit and it did not include a boost reactor or an AC inverter assembly within this unit. Down in the bottom left then you see the second generation, which maintained about the same footprint as that first generation. However, this did add in a boost reactor as well as the AC inverter assembly on the bottom half of the inverter. And last but not least is the one over on the right. That is the third generation Toyota Prius here in the US, the 2010 and later. That inverter assembly has all of the components, for the most part, that the second generation had in it. However, you'll notice it is a much more compact unit. They've been able to shrink the size of that down significantly, and about the only thing that's not in that unit that was in the second gen is that they've actually moved the AC inverter out of that unit and moved it into the AC compressor itself. Obviously, this was just a very brief overview of an inverter assembly on a hybrid vehicle. We didn't get into the in-depth operation at all, and it is a very in-depth topic to cover the actual operation of the inverter. So a couple of main things to remember. First of all is that all hybrid vehicles are going to have an inverter. They actually need to have an individual inverter for all of the electric machines being driven on that vehicle. Now, they may all be housed in one unit, but they are all technically individual inverter assemblies. Second, keep in mind that the inverter itself, the larger box, may contain more than just the inverter. It may also contain things such as a DC to DC converter, an AC compressor inverter, and some other units like that. The other thing to keep in mind is that if you do actually experience an inverter problem, you very well may have a vehicle that is displaying a no-drive condition. The inverter is a critical device that the vehicle really cannot drive without it if it's an electric drive vehicle. If it is one of the parallel systems like a Honda Civic, you may still get drive, but you will have no additional assist coming from the hybrid drive system if there is actually an inverter failure. Thank you for watching this hybrid vehicle tech tip brought to you by P10. If you'd like more information on inverter assemblies, check out the P10 training segment on hybrid inverters as well.